I'm going to be talking about UMA, which lets you bring the truth on chain with an optimistic oracle. It's a pretty open-ended system. There's a lot of cool things you could build with it, and we'll dive into a couple of them and how you can get started quickly. So the basic idea of UMA is that it's an optimistic oracle. It can provide and verify any arbitrary data on chain to secure smart contracts and execute things based on what's happening in the real world or based on cross-chain events or off-chain calculation. It's been called a human-powered truth machine, and the reason for that is that you can and often do use bots to automatically propose and dispute and so on, but UMA is able to handle natural language questions and it's able to apply human reasonableness. So unlike a price feed style oracle, it's not trying to determine in advance and then push a price on chain. Anybody can basically ask a question, anybody can propose an answer and post a bond with it, anybody else can dispute that answer within a challenge window. And we'll get into all the details of that. So oracles are really important. I personally think that the next phase of crypto really needs to bring in more real-world events, more real-world assets, that kind of thing. And oracles are critical to that. The OO is powered by UMA token holders. It can be plugged into any kind of DeFi protocol or other on-chain smart contract. And it's super, super flexible. It's been used to build bridges, insurance protocols, prediction markets, derivatives. We have some optimistic governance stuff coming out soon that's really cool. So here's what goes into it. The basic flow, you have a requester. The requester is asking a question for some data. A proposer provides an answer, and a disputer can challenge the answer if it's wrong. It has a dispute resolution process, so if it gets disputed, it goes to a vote of all of the UMA token holders that do a secret commitment on chain of what they think the answer is, so you can't copy other people's answers, and then a reveal process where the actual answer is revealed. Documented methodology of truth, so you describe your methodology of here's the kind of information that I'm looking for, here's how you can figure out what the answer is. So if you have something complicated, there's one project that wants you to calculate volatility of an asset, which is kind of yeah, okay. Are you with volatility now? Okay, there's two projects that are trying to calculate the volatility of an asset. So for that, you need to kind of explain to people, here's how you calculate it. You might provide even a script to do it, or some backup process to do it by hand. And then you have economic guarantees, so people have money at stake. If they're wrong, they're going to lose money. If they're right, they're going to make money. So that's kind of the combination of things that you use to build an optimistic oracle-powered thing. And this is just kind of a flow chart of how it works. So it kind of starts with a question. The proposer posts a bond and gives an answer. If it gets disputed, then it goes to this DVM process where all the UMA token holders weigh in on it. But because of this proposer bond, disputes are extremely rare. I think maybe 1 out of every 500 proposals, and actually probably less when a cross-chain bridge is taken into account, because proposers don't want to lose their bond. So normally you just say no after the liveness period, the challenge window, you have the final answer and you can use it. So these are some things that have been built. I talked about this a little bit. KPI options and success tokens are some really cool DAO tools to incentivize communities, incentivize investors in a way that's really aligned. And there's much, much more than this, and I'm very excited to kind of see what hackers come up with. I know the last couple of hackathons, we've had some really cool stuff. We have a Decentralist here, so it's verifying lists of addresses that meet certain criteria, which is a really flexible tool. There's a cool project from ETHBogota where you're verifying news information, basic facts. You can check it, you verify it, and now you have a corpus of facts that you can deal with and really trust for the news. These are just small examples. There's so many different things. Yeah, just some examples of questions. So again, you can ask natural language questions. You don't need to even have an API that you're pointing at. You don't need to have nodes running in the background. You just need a question that someone can answer, that somebody with access to Google basically is able to determine what the answer is. So our oracle can also be triggered by events. So if you have some event that you know is going to happen in the future, you can essentially set up a trigger in your contracts and provide incentives for people to inform the contract that the event has happened. So for instance, if you wanted to have some kind of a payout, maybe if ETHSanFrancisco was canceled and you wasted a bunch of money on plane tickets or insurance or hotel costs, you could have an insurance contract that'll pay out. That's event-based. ETHSanFrancisco hasn't happened yet at the time you're buying this insurance. But then when ETHSanFrancisco does happen, you can resolve this it happened, there's no insurance payout, or vice versa. And then those events can flow into other contracts. So once that is settled, you can have a callback function in your contract that when the oracle resolves the answer, your contract will automatically do some stuff. And the reason for that is when you're making the request, you're saying like, hey, I have this callback. So when the oracle is resolving, it's going to call this price settled function in your contract, and then you can do all of your other logic, including like in this example, just doing an insurance payout automatically. So all you really have to do is ask the question, include the reward, the incentives are there. Essentially, this decentralized keeper network is going to take care of it for you now, both verifying the truth and triggering all of your events that happen. So now the real world can directly affect on-chain state. So if you know something happened in the real world, that can now affect a smart contract, and you can build the incentives in place that that information is going to come in, and then all of your smart contract logic will play out in this permissionless and unstoppable way. You can also use it to make assertions, and this is a pretty common pattern where you know what the answer is, but you don't want people to just trust you. So you come in and you ask the question and provide the answer at the same time, and then you can use that answer after that challenge window is over. So that's actually probably the majority of projects might want to use this pattern. And the insurance one is a good one too. Like you might trigger the request and the proposal at the same time. There's no point to even necessarily making the request unless the thing has happened. So as the person who's getting the payout, the money's locked up in the insurance contract, ETHSanFrancisco is canceled, you just go and say, hey, it was canceled. Make the request, propose it, and then you get paid out after the challenge window. And so this is kind of like a way to implement that. And really what it's doing is just like wrapping the other functions. So you're requesting here, you're setting a liveness period of how long the challenge window should be, because that's customizable. You might make it longer or shorter depending on your use case. And then you're proposing a price and just emitting an event so that front ends know about it. So you can ask questions about past events, you can subscribe to updates about future events, you can trigger callback functions, you can make assertions about the world, and you can build a collection of undisputed facts on chain. And voila. So this is the real world. This is what we're trying to bring on chain here. Most of the stuff that matters is happening out here. It's not just like the circular kind of crypto economy. This is kind of the next phase that we need. This is what we need oracles for. So we have like a lot of tutorials. I'm going to pull up one that's just like a really basic quick start. But depending on what you're working on, you might want to go to these more advanced tutorials. We have something for like a just basic deposit box. You're putting money in and then you're pulling a different amount of money out depending on the oracle's response. We have a prediction market tutorial, so you could deploy a prediction market. An internal optimistic oracle, and this is just kind of demonstrating a pattern where you might have an escalation game before you even go to our oracle, where you only come to us if there's a dispute, for instance. We have an insurance tutorial, and then something we call the optimistic arbitrator, which is kind of showing that assertion pattern. So all of these things are like too long to get into right now, but go to docs.umaproject.org/developers, and you'll see all of our tutorials that are available. But we are going to go to the quick start one. So the quick start also includes a video. This is me in the distant past when my hair was short. And this is just going to ask a really simple question. How's the text looking, by the way? Is it like small or? Okay. Oh. Okay. So it's just going to ask about the temperature in New York City on a certain day in the past. And then you're going to answer yes or no depending on the temperature. And we're just going to deploy something to Gurley testnet and just like walk through a basic flow. So let's go to Remix and check this out. While Remix is loading, I'm going to click over to our Oracle interface. So this is something that you could use to manually respond to requests that you've made on Gurley. So if you're testing on Gurley, you could go here and do like an actual like natural flow. You'll see the requests come in, and you can respond to them. So it's a more realistic kind of simulation. Request failed. Well, it looks fine though. Okay. So this is our contract. It's just a really simple getting started contract. I'm not going to go into all the details of it, but I'm basically just going to go and deploy this to Gurley so we can interact with it and then walk through the different steps. And again, if you go to the quick start tutorial page, you'll be able to pull this up and it'll make it pretty easy. You'll need some Gurley ETH, but we have some instructions on how to get that if you don't with the addresses that you're using. All right, so that's confirmed. We just deployed the contract. We should be able to interact with it now. So let's go and run some transactions. So right here, we're going to start with this request price function, which don't get confused when you see the word price come up in our code. UMA kind of started out with a lot of financial derivatives focus, and so there was like a lot of focus on price. Just mentally replace the word price with data in your mind. You're requesting any kind of data. So this function is just going to ask like a pretty basic question, what we've defined here, like did the temperature on the 25th of July in Manhattan exceed 35 degrees Celsius? And then it's providing some instructions for your proposers on like how to resolve it, because they're going to have to return a number. So 1 means yes, 0 means no. You're just letting them know here. So we're going to make this request. Confirm that. And then once this goes through, we should see this pop up in our interface here as a new request. Okay, so we got a new request here. I'm going in just like a manual proposer. I'm seeing new stuff that's coming in. Pull this up. Gonna connect it to my wallet so I'm able to propose. And I can see the question. So did the temperature exceed this? 1 for yes, 0 for no. And again, it's not specifying a data source. It's just kind of up to the proposer to propose something that they can stand behind, that they're willing to risk their bond on. So I'm going to go to this random website because it's a testnet thing, so I don't really need to like check multiple sources here. And it looks like the max was 84 degrees Fahrenheit. Run the conversions, manual kind of thing, and that was definitely under 35 degrees Celsius. So I'm going to read this again. 0 is no. I'm going to propose an answer of 0. And since this is a testnet request, I think the wait period is going to be like 60 seconds that somebody could challenge this. And it might actually be so fast that you won't see the dispute option come up here. But once this goes through, you should actually be able to dispute it also through this interface. So you can test out that flow as well. And if you're on Gurley and you're doing this, we have a mock Oracle contract, and there's some documentation for that online. You'll get like 24 or 23 seconds left if I wanted to dispute myself. But if you want to like resolve a dispute, obviously there's not going to be a full vote on this on testnet. That wouldn't even work. You can just basically like push an answer, and that'll simulate getting an answer from the DVM, the dispute resolution process. But in this case, we're just going to let it wind down. Everybody thinks this is correct. Other people checked the same sources. Seems like the answer was 0 for no. So now that that's gone through, we should be able to actually settle this, kind of following through it. We proposed, and we're going to call the settle request function, which you could also do. Okay, so this remix hasn't updated yet that this is settleable, but it will in a minute. Okay, now we can do it. So basically, you saw it fail because it thought that we couldn't settle it yet. It didn't see that like the countdown clock had gone down. That was just kind of like the node updating with the actual state now. Going to confirm that. So once this is settled, we'll be able to actually use this answer for whatever we're interested in. Maybe this is like, again, like an insurance contract tied to the weather or something in New York. Give that a minute. Looks like it's pending. Okay, so we were able to call get settled, and I don't know if you can see it down here, but Remix actually gave you the answer. So 0 is the answer. We can now use that. That is finalized. So that's the really basic quick start. I really encourage you to go into the more detailed tutorials. Like here's a prediction market, for instance. All of these should have instructions for actually deploying these on testnet or your local environment. And it just really helps you think through like different things that you might want to implement. There's also good instructions for setting custom bonds and liveness parameters. This is something that you would think about in a mainnet thing because the bonds are going to provide basically a penalty for proposers that are bad and a reward for disputers that are good. And you need to think through like what are the correct levels. You don't want the bond to necessarily be too high because then people are scared to propose. You don't want it to be too low because then people don't have an incentive to dispute. If you're securing like $100 million, you're going to have a lot more to think about than somebody securing like $1,000 too. Like all of these things are configurable, so just think through what makes sense for yourself. So the minimum bond is what we call the final fee, and that's just like an anti-spam thing, and it's about $1,500. And the reason for that is to block people from just like spamming the DVM and farming voting rewards. Because the incentive as an UMA voter is you get rewards if you show up and vote correctly. So people would have an incentive without that final fee to just create a bunch of fake disputes just to like farm a bunch of like UMA tokens for themselves. You generally want to set it higher because only the amount in excess of the final fee is going to go towards the disputer's incentives. So if you set like a bond of 4,000, half of the excess is going to go to the disputer. And this is kind of like a complicated thing, but basically like with a $4,000 bond, if somebody disputes and they're correct, their reward is going to be $1,250. And then 1,500 goes to the store, and like I think the rest also is going to the store in that case, just to keep people from proposing and then disputing themselves, like front running a dispute that came up. But yeah, so like if you don't give an extra bond, disputers have no reason to show up. They won't make any money. So you do need to like set it higher than the final fee, unless you like have some extra protocol kind of incentives for people to show up and dispute. Like you're running bots, you know that lots of other people are running bots, and you don't need any extra incentive. They're just going to like show up and dispute because you know it's wrong. Wanted to point out prizes too. So basically, first place, $5,000. Second place is $2,000. And this is for UMA or Across. I didn't really get into Across in this presentation, but Across is a cross-chain bridge that uses UMA under the hood. You can use it to move between Ethereum, Arbitrum, Optimism, Boba, and Polygon. It all has single-sided liquidity, so no slippage. It's usually the fastest, cheapest bridge between these chains. So if you're building something cool with Across, you could also qualify for prizes, and it uses UMA under the hood to verify that transfers are done correctly. And then there's a pool prize of $3,000 that's split between all the teams that do any UMA or Across integration. So there's an opportunity even if you're not like one of the top prize winners. But we have some more time. I did want to like get into what people are thinking about building and maybe like brainstorm, how you could do that with UMA or with Across also. Prediction market? Okay, we've got a tutorial for that. You can get this deployed in an hour. You're done, and then you kick back your heels and relax. And mm-mm. Mm. Okay. So like a request for quotes? Okay. Let me think about that. So the quote comes in. Is that coming in like on-chain or off-chain? Mm-hmm. Interesting. Yeah, I mean, it seems like an opportunity that you could gather in a bunch of bids like off-chain where it's cheaper. And then the highest one could be like pushed on-chain. So you could basically say like, building on top of Seaport, and just spitballing here, somebody has posted an RFQ and they're like, I want a minimum of this for my Bored Ape, but not everybody wants to go on-chain and spend gas to put in a bid and possibly not win. So they go to some like kind of off-chain broadcast thing, and there's some set time period, and the winning bid, the highest bid, can be proposed now on-chain, and UMA can verify that that was actually the highest bid. If it wasn't, then it gets rejected, or if like the time period hasn't exhausted itself, it'll be rejected, and that'll be a way to like bring that off-chain highest bid on-chain. Mm. Yeah, I mean, you definitely could. I mean, you could use like UMA because UMA can see what's happening on every chain because it's just like whatever like human beings can look at or bots can look at. So if you have a RFQ that's coming from some other chain, you might use UMA to automate like moving funds to the chain where you need to actually like make the payment. Like if you're like your funds are on Ethereum, you need to move them to Polygon for something and you're asleep, but you know that you want to like buy this type of Polygon NFT as long as one comes in at a certain price. You could use UMA for that. Like basically give people an incentive to like move your funds on your behalf and then submit the bid. So it's like what we were talking about with those event-based triggers. You have some new real-world event, an RFQ came out that you're interested in. other people can now like trigger some stuff on chain that's going to like move your funds in place to actually bid, and you'll win this auction in your sleep. All right, after the prediction market. Yeah, you definitely could. Like if you see, yeah. Mm. Yeah, that's interesting. Yeah, so if people are like submitting things on chain, or you could also, I don't know with Seaport if you're able to like rescind a bid. Like if you put in a bid and then you're like, wait, never mind, something else more important came up. Like maybe you're able to like pay attention to that too. So if you're building like an NFT trading bot that is keeping track of like what is the most important thing, maybe you rank like the NFTs you want the most, and so you like pull one bid because you need the funds for some other thing. I think you could probably do that. I think there's also probably a way, NFTs get stolen all the time, so you might not want to bid on one that was stolen, and so you might like add like a check basically where it's like, um, I don't know, like anybody can do this and submit this bid on my behalf, like unless it appears from whatever evidence that this might have been stolen, and then there's some kind of like delay baked into that, so that you're not like, otherwise somebody could come in and like steal something, create an RFQ, use this automated system to have you bid on it and sell it to you in an automated way, and they won't be disputed necessarily because you did say you wanted it. You didn't specify you don't want it if it's stolen. Yeah, but it's like also very active because it's like in real time. It's like this specific NFT, did it happen to be stolen? Can you like tell within this time period? So that seems like a pretty good protection against doing that, as long as it's like a long enough time period. Right, exactly, yeah. Because you're not going to know in advance that it was stolen. It's like probably newly stolen, up for sale immediately. Yep. Yeah. So the return value is always going to be a number, but you're able to ask the question in a way where you can like kind of say what number to return based on what the actual return value is. So yes or no is an obvious one where it's like 1 means yes, 0 means no, 0.5 means this one's not resolvable, and just kind of like split the difference. But you could have like more complicated types of answers too. Returning a struct seems tricky. You could probably also do like, like encode something like as a number and just really specify somewhere, maybe in your like price identifier that went through UMA governance of like, here's how you convert the end result into a number, and you're returning this number value. And then you know to like convert it back the other way in like such and such means. Yeah. Yep. So the identifiers are approved on-chain, but the methodologies are stored off-chain. So you would go to like the UMIP kind of description of like how to resolve yes or no query, for instance, or yeah. It's on GitHub right now. I think it would be better in the long run if we had some kind of like an IPFS type thing so that it's immutable, but right now it's on GitHub. Cool. But yeah, like I said, it's super flexible. We've got the booth. It's on like that side at the end of the hall. We'll be here pretty much all weekend helping you hack on stuff. And we really want to provide as much support as we can because, we want cool stuff to be built. We also want to like help you make it to like the finale and like achieve all your other goals. And then, afterwards, we do have like grants programs. We can provide follow-on support. Alex is here in the audience too. Like we both help hackers like extend their projects. And we're also hiring too. So if you're interested in working for us, we'd love to work together with you over the weekend and then, see if you want to apply to that. And I think that that's it.